Assalamu alaikum everyone. We are going to continue our discussion on coordinate geometry, and in the previous video I have discussed gradient or slope of a straight line. Now we are going to learn distance formula in a rectangular coordinate system. This is one more very important thing in coordinate geometry. I really hope that you have understood the previous topic, and now we are moving towards the next topic, which is distance formula in rectangular coordinate system. As the name itself suggests that we are going to find out some kind of distance. When I say distance formula in rectangular coordinate system, so that actually means we have to find out the distance between the coordinates given on the rectangular or the Cartesian plane. This is the plane that I already have. I am not directly jumping up on the formula. I am only going to introduce you how the formula, why the formula is constructed. First of all, this is a rectangular plane. On this plane, you can trace any point, coordinates of any points. You are familiar with those things. For instance, I am highlighting 2 points here, and I would want you to find out the distance between them. For instance, the first point is here. This is the first point. I hope this point is visible, and the coordinates of this point are 1, 1. I know you cannot see the coordinates from this part. That is why I have named it one. I have plotted the points 1, 1 and mentioned the coordinates. And then there is one more point here. This is 1, 2, 3, 4, 5. Here is the point, and the coordinates of this point are 5, 1. So these are right now the 2 points that I have plotted on the plane. First point is 1, 1, and the second point is 5, 1. If you look at these 2 points, you can very easily understand that these points are not changing along y-axis. They are traveling along x-axis, but there is no change in their distance along y-axis. So if I talk about these 2 points and I talk about their distances from the coordinate coordinate axis, so what are the distances? This point is at a distance of 1 unit along y-axis, or I can also say this point is 1 unit away from x-axis. In the similar way, this point is 1 unit along x-axis and 1 unit away from y-axis. On the other hand, if you talk about this point is 1 unit away from x-axis and 1 unit along y-axis. And then again, this same point is 5 units along x-axis and actually 5 units away from y-axis. So you can very easily find it out, a point, how far is the point along an axis and how far is the point from an axis. Anyways, so if I talk about the distances of both these points along y-axis, they are same. There is no change in their vertical distances. So obviously I cannot measure how far apart are they from each other vertically. They are at no distance at all. Okay? This is 1 and this is also 1. So there is no distance between these 2 points vertically. But when I talk about their distance horizontally, how much is this distance? This distance is 1 unit. And how much is this distance? This distance is 5 unit. So I can see this distance, the distance of this point from the y-axis is 5. The distance of this point from the y-axis is 1 unit. Let me just mention it. This distance here. How much is this distance? This is 1 unit. And how much is this distance? this distance. How much is this distance? This is 5 unit. And now if I ask you how much is going to be the distance between these 2 points from here till here. So it should not be a very big problem. I'll subtract 5, 1. This is 5, this is 1. I'll take 1 out from it. So this distance is going to be 4 unit. So you can very easily comprehend or understand or make out that when there are 2 points which are not changing vertically, the distance between those points is actually the difference between their x components only. For example, 3, 2 and 7, 2. These are 2 points. Their x components are changing, but their y components are not changing, and I only want you to find the difference, find the distance between them. So this will be the difference of these two. 7 minus 3 is going to be 4 unit. Where is this 3, 2? 1, 2, 3, 1, 2. This is 3, 2. And where is this 7, 2? 1, 2, 3, 4, 5, 6, 7 and 1 and 2. So here it is at the very end. So these are the 2 points that I am talking about right now. Are they vertically apart from each other? No, they are not. So obviously there is no distance between them vertically. But when I talk horizontally, what is the horizontal distance? This is 7. And what is this horizontal distance? This is 3. So 7 minus 3 will only give you the distance between these 2 points, which is again 4 unit. So when I talk about any 2 points, whose x component or y component, any one of the components is fixed. So to find out the distance between them, I can just simply subtract the components which are changing. One more example. Let's say 3, 9 and 3, 2. So in order to find out the distance between these 2 points, what are we going to do? 3 and 2. Their x component is not changing. It means there is no change there in their horizontal distance. But vertically there is a change. Vertically one point is 9 units above, the other point is 2 units above the x-axis. So the distance between them will be 9 minus 2 is 7 unit. As long as we have such points in which either x or y component is constant, then we only take the difference between the varying component. But the situation does not remain like this all the times. You do not always get these kind of points. You might get point like this, 3, 5 and 2, 7, maybe 2, 9 and let's say 9, 2. You can get these kind of points as well. But obviously when you have these kind of points, you cannot just take out the difference between any one of the components, because both the components are changing. In this case, the y component was not changing, it was fixed. I took out the difference between the x components only, found out the distance. In this case, the x component was fixed, y component was changing. I took out the difference between the y components and then I found the distance, as I have mentioned or I have explained. I hope this explanation is clear. But when we have these kind of questions in which both the components are changing, you cannot just take the difference between both the components and tell me the distance. There has to be a different way. That is where distance formula comes into use. So in the next video, I'll be continue discussing this distance formula thing, and in that formula I'll discuss how to find out the distance between 2 points in which both the components are changing. For the time being, you should be able to identify when we have to use the formula and when we do not have to use the formula. In these 2 cases, the formula is not to be used. You can find out the distance directly by just taking out the difference between the varying component. that fixed component does not need to be subtracted. And this is the case where we are going to use the formula that I'll continue discussing in the next video soon, inshallah. Thank you.